My name is Michael. I'm a developer and a consultant working for ThoughtWorks. I come from the beautiful city of Hamburg. And 2 years ago, I gave a talk here. And the title was 50,000 lines of code to brew a cup of coffee. So that was my personal first IoT project where we built a coffee machine and the components around it. And I summed up some of the lessons learned together with my colleague Martin on this project. Now, 2 years later, there were more projects. There were forklifts to be connected, cars, charging poles, and different things. And the goal of this talk is to summarize the lessons learned from these projects and hopefully to give you an idea how to approach the Internet of Things. So when I first heard a couple of years ago about the Internet of Things, I was like a little kid. I was sitting on the train, dreaming about how my life will change, what devices will be connected, what can I do with them, and I was very, very excited. Today, I'm still excited, but I understood that if you take the Internet of Things, it describes the state of the Internet. It describes the state where most information that's produced and consumed is done without any deliberate human interaction. And as a developer, I'm like, how can I create the Internet of Things? And I understood I don't have to worry about this because it will just appear once we connect more devices and we just do more projects. It's very similar to, remember those days when people talked about Web 2.0? Everybody was really excited about this and people were like, we need a Web 2.0 website. All of a sudden, people stopped talking about it because it was there. But if we now ask ourselves, how can we approach the Internet of Things? It's worth to dig one level down. And the next level would be the smart domains, smart mobility, smart agriculture, smart cities, smart home. So you have different systems connected to each other to be useful with being actors and sensors of data. But again here, I myself, I can't just build smart mobility. And probably no company itself can do this. Some try, but probably they won't do this. So again, we should go then one level deeper, and there you have something called a multi-layered ecosystem. So for example, if you think about your home, you might have different devices connected to backend systems and interacting with each other to make something useful. You can think about a smart factory. There's machinery, there's logistics, there are production lines, and all the systems are actually not one system, but they're just connected system by itself. Again, this is very hard to implement. So then comes the idea of a smart ecosystem. So you have a connected device that is tied to some backend, and it has useful services around that, so that there's an extra value for the user or for the owner of the system. And this is where the word smart ecosystem comes from. To make it a bit more clear, I'm going to start also from bottom up. So if you take a device, and yes, you will still see coffee machines in this talk, the device itself has a functionality. In this case, it brews coffee without even being connected, and hopefully it brews delicious coffee. If you then put a small PCB, some computing power into the device, you are able to put in some logic that might make the brewing of the coffee more efficient or more delicious or something like that. Then you might call it a smart device. So for example, the heating system I have in my basement, it's smart. It changes stuff as the temperature is changing, but it's not connected, and I wouldn't call it an IoT heating system. If you then put connectivity into the device, so then you have something that has functionality, and it has some logic in it, and then you connect it to a backend system or to the internet just in general, then you can call it a connected device. But there the additional user value is very limited. I mean, most of the time you see with IoT devices, you just have an app and you see some values. Exactly the same values you could basically read on the machine. Not very useful. But then you need to put extra value into your backend system and the services around it, and then you have the smart ecosystem from the bottom. So summing it all up, Smart ecosystem seems to be, for most companies, the right way to approach the IoT. Because if you start just with a connected device, you don't have any additional user value, and people will actually be quite disappointed because they spend all this money now on an expensive device that doesn't do much. On the other hand, if you aim for the multi-layered ecosystem right away, it's probably very hard to implement this as a single step. I hope this gives you some idea when I talk about smart ecosystems, what I mean by that. Well, I didn't come up with this word. It's also used by Fraunhofer a lot, and they have a very different definition, because they say smart ecosystems are a software system that are combining these different types of systems. So for example, a backend system is more or less an information system. We most of the time build it in Java, C# or whatever, and then there's a mobile component to it, either for the connectivity or it could be a mobile app, but mobile systems feel a bit different than information systems. What's very different about smart ecosystems is that most of the time you also have an embedded system. This stuff that is running inside the machine, where you have limited resources, where you have a different language, and you have to connect it then by a mobile to your information system. So their idea is that the smart ecosystem combines these different types in one system. I'm a developer. I wish I could tell you now the most important thing for building smart ecosystem is the architecture and the tools and the protocols. The past shows, at least from my experience, it's not. So the goal of this talk is to highlight all these topics you see around there on a very brief level, because all these things are important factors for building a successful smart ecosystem. And honestly, there are some topics I'm not really passionate about. Organizational design. I couldn't care less, but it's important. Start with the first one. Business models. I'm a developer. I'm speaking about business models. What I do know is there's technology and there's business. And there's an interaction, a relationship between those two. Technology enables new business. And business drives then the technology again, how it's evolving and how innovation is done. And the faster you can turn this wheel in your company, so the faster you can make technology actually be useful for the business, and the faster you can make the business then drive again the technology, the more innovative you probably are. It seems that in the past people got a bit overexcited about the idea of Internet of Things because they broke this wheel. So you have, on the left side, this is a connected egg tray. On top of that, you have a connected water bottle. And then there's a connected hairbrush. And maybe some people find it useful. I guess the success of these products show that you have to step back a bit. What do people really want? Not just put the same product you have, just put smart in front of it and give it some connectivity. Do you know these watches? They measure your pulse and your heart rate. And these have been around forever. Not forever. So in the 1990s, these watches were able to measure your heartbeat. And actually, if you would have the right cable and the right operating system, you were able to connect it to your desktop and then download the data. And then you can, I don't know, you have a CSV file and you can import into Excel and make a graph out of it. That was it. Later on, these things were then connected to web or mobile apps. So you didn't have to do the tedious connecting and downloading and importing and then analyze how your heart rate was. So that got a bit easier. And now we are in the next step. So we can not only take our heart rate when we exercise, we might have a connected scale, we might have a diet plan, we might have our training schedule, and we can connect all those things. So if you think about the ecosystem that started with this product, this watch moved from being an instrument measuring an integer value to an analysis tool for your exercise. And now if you're a bit euphemistic and optimistic, you might be able to call it even a training assistant. And the thing is, if you then step back, people actually don't want this watch. They want to run faster, or they want to lose weight, or I don't know. And so they don't want the product, they want to achieve something. And if you then think about the different evolution steps of this watch, it started with being an instrument where the things that this device, that this product can do for you to achieve your solution is very, very limited. But the more information you put into the system and the more you focus on what the clients actually want or the users want to achieve, then you can push this, what can be automated to achieve this solution, forward, so the human has less to do with it, which is interesting. I guess one good example is this one. Everybody knows this one? The Amazon dash button. Sorry, you can't see. It's the Amazon dash button. Problem here is I'm standing in front of my washing machine and I'm running out of detergent. The solution is I get more detergent. The human interaction here is I have to press a button. And the product itself is very stupid. It's a switch. It's a switch that is connected to a Wi-Fi. That's it, right? Nothing special. It doesn't even have a core functionality except for being clicked. But the services behind it, I set up my address, I set up my Amazon account and things like that, actually solve almost the entire problem for me. All that's left, I have to wait a bit and have to open the door. That's it. Problem solved. So if you think about, if you're in a company that's manufacturing and selling products, I guess it's time with the new possibilities you get out of connected devices to step back and to ask them again, okay, do people really want an excavator, or do they want just a hole in the ground? And maybe we can charge them for holes in the ground rather than for buying machines. And I mean, especially if you look at the German manufacturers for industry vehicles, they moved from selling products and vehicles to leasing them. Maybe it's time then to move to the next step. Let me give you an example. All these players are somewhat in the mobility sector. And do you know their claims? So at least until last year, Volkswagen had Das Auto, the car. It's a product. Sixt has the claim rent-a-car. And Car2Go, I think they also changed it, but I really like that one. Hello Mobility. So there you can see the strong trend from a product to, let's say, a standard service to a very ad hoc and individual solution. You can have the slides. Oh, that's my favorite topic. Organizational structures. When you think about building a smart ecosystem, there are lots of things that need to be done. I wrote down a few of them here. Maybe you can think of even more. So you start from the hardware side, firmware needs to be built, the device needs connectivity, you then need a platform and infrastructure in between to have services that then a user has apps, and for this obviously you need to analyze the business and you probably want to do some user research. If you then have a big company that is able to do all this, then at least you can find you need different people for this. I myself can't do all this. And in real life, these people are in different teams, in different departments, in different buildings, in different sections of the company, maybe even in different companies. But you need all of these people. So what I've seen in the past a lot is just put more hierarchy in. Steering committee, weekly meeting, two hours every Monday, scrum of scrums, and on the bottom then you have one businessman organizing it all, and probably this person is really good at organizing things, but we know as technical people, if you then need to integrate this, actually on the bottom is where the problem is. I thought it was an integer, now it's a float. I thought this would be this unit, and it's not. And so what people then tried a lot, or different companies tried a lot, is to, however it's called in your company, innovation lab or startup within a company. So they take different people out of this and try to build a cross-functional team that can handle all this. And to be honest, I've seen this working quite well. People are coming together, they're out of their old environment, and they are able to put together a proof of concept or, some prototype within months. What I've also seen a lot is this doesn't scale back. Then this group of people was able to create something on a prototype level, on proof of concept level, and then it's, okay, now we have to go to production. And then you're back in your old structure again all of a sudden. And to be honest, I don't have a silver bullet for that. But I want to add one more thing that is also a very common pattern. I'm staffed 50% on this project to explain you our API. So that was exactly the sentence I heard from a person on my team. And then I thought, well, what does 15% mean? That will be the Monday from 9 to 2? Or every day? This doesn't work. And this seems to be a lot an excuse in big company structures that, oh yeah, we want to do this, but this is not our core business, so you just spend 20% here and there. This doesn't work. People are not bought in, people don't have the context, and you don't have the interaction and the integration you need then on the bottom level. Oh, another topic, that's not my core skill. Experience design. For 15 years, I've been trying to build software with the help of designers that looks good on a screen like this. Maybe bigger, maybe smaller, but we wanted to have a really good user experience on a two-dimensional computer screen. And in the past, I don't know how many years, we fought very hard to make the same experience as good to look good on the screen that is on a mobile phone. So we came up with our nicely crafted navigation structure and put it into a burger menu. And we came to the idea that instead of putting things side by side, we just put them top to bottom. And honestly, it works. I'm happy with most of the websites and software I see on my phone, and I can use it. And then you have this. You have 5 buttons and a screen that is like that. And it's not a touch screen, and if it's a touch screen, it's resistive, not capacitive, so it's really ugly. And then you have user flows across those devices. And so I guess we have to move on, from those computer screens. So right now, if you think about UI design, we have to think about those tiny screens, or maybe LEDs, or maybe, I don't know, whatever this machine has. And also about our mobile phone, and also about our computer screen. We have to consider the industrial design. How does it feel? What's the form factor? How in the user flows is this thing giving feedback to the user? And the hardest bit is the interusability. What happens if I press the button here on the phone? How should the machine then react? So I guess if you then have your experience designer sitting with you, you might want to get in an industrial designer for some inspiration. You might want to have discussion about flows. And I don't have an answer, but I identified a few topics that are really useful to focus on. First of all, user experience beyond the screen. I think I already alluded to this one. Latency. With phones, we got a bit better, but right now, just pushing a button and then show a spinner until the machine finally receives whatever it's supposed to do and then sends back that everything is okay. Spinners and page loaders don't work anymore. And offline. Everything that can be connected can be offline. So if you have a user flow between different devices, you always have to consider literally every case. What happens if the mobile phone has a big latency and a bad connection, and the machine has been offline for 2 days and stored, I don't know, 200 events it wants to send back? So you have to consider this from a user perspective. You have to give feedback. I had a device that had an external Wi-Fi connection, and there was only one LED on there, and it could show green, yellow, and red. And if it would lose Wi-Fi connection, it would be red. I know I don't even have to try something on my phone, which is not the best user experience, but at least I got feedback that I don't have to try anything else. And we want to hide technology. Nobody cares if it's a Wi-Fi connection or a SIM card or whatever processor is behind it, or if it's booting up or getting updates and synchronizing. Nobody cares about this. I have something, in this case, a coffee machine in front of me. I don't care. Just give me coffee. So lots of areas where we have to work on, and nailing it down again. If you think about this device, and it doesn't matter what it is, I just took something. The first thing you want to worry about from a user experience perspective is the connectivity setup. So people are buying these really expensive products. They're all excited, going home, unpacking, and then they have to do this. I took notes from the YouTube video that is explaining how to get connectivity onto this device. So you have to register, then you have a key, you have to do this key ID, you have to write it down somewhere, then you attach the Wi-Fi module, then it does a firmware update, you have to wait, then you have to select the Wi-Fi, enter the Wi-Fi password, then you wait again, then it does the synchronization, which again takes time, and then you have to accept the privacy policy, and then you are done. I guess this will take about half an hour, I guess. And the thing is, this is the happy path. Because you have to type your Wi-Fi password on this screen. I mistyped it, sorry. So when we built the coffee machine, this probably took 30% of the time. The initial process, how the user sets up the Wi-Fi. And I think it's worth, if you have this problem, to look just at different products. How is an Amazon Echo set up? How is a Dash button, a GoPro? Because I'm not going into detail of this. They're just different, let's say, ways to get connectivity that makes sense for different devices. If I have a GoPro camera and I need to set it up once, it's probably fine if I just attach a cable, because I'm going to work with my computer anyway together with this. For other devices in the kitchen, it might not make sense at all. Again, for industrial machines, probably it's fine if somebody just needs to come in and plug something in. It's good. Architecture. So when I come to a new project in the IoT area, usually I meet somebody that has architect in the title. And then we have the first meeting, and this person then explains to me what their technical vision is. Interestingly, they all look the same. So we start with a fresh whiteboard, and then the person says, we are not building here an IoT device or a smart ecosystem, we are building the company's internal IoT platform. And then they draw this. So on the left-hand side, you have the different devices. In the middle, you have their IoT platform, which usually has these components. For some reason, people start thinking again that rules engine are a good idea. And then you have services on top of the platform, and then apps on top of that. And, well, we all know, I mean, have you ever tried to build upfront the library, the framework? Did that work? And I guess the same is with platforms. And the anti-pet and the smell, you always see that they always put the focus on the platform. And then they realize, oh, we don't have any data. So then they put a bit of focus then, oh, let's get some device connected for our multi-purpose platform. And I rarely see then somebody building apps on top of that. Maybe sometimes, just a showcase thing that just shows the value from the device going through the platform and then on a screen. Yes, I guess platform envy is how you can call this. I've seen this happening a lot. So how about what we do with web applications as well? I mean, the first thing we do is we put a login screen there that is to just see I can show something on a browser that goes through my backend that is connected to the database. It's working, right? And then I can build on top of that and adding functionality. And I guess you should do the same. You don't know what protocol is the right one for your use case up front. You don't know how it will scale and where the bottlenecks will be. So just getting one thing end to end is not only good from a technology perspective, but also from an organizational perspective. To see if you have set up a team that actually can put things together. Also, management will be happy to see something on the app because nobody cares about console output. I played around with the Echo a week ago, and I wanted to fake a home device. So I thought that my Echo would then speak directly to my fake device. It does not. It just needs some backend URL. And then basically it's talking, the Amazon Echo is talking all the time to the backend, and then the backend would talk again to my device. And then I was like, oh, this is boring. But then I understood, right, because the Amazon Echo needs internet connectivity to do the speech recognition. So in this case, it makes sense. But this is actually how most IoT systems work. The devices speak directly to the internet. And I mean, this works as long as the device itself has the core functionality, but I don't want to have a smart home that basically stops working when my ISP hangs up. And I guess the term here that I don't like it, but it seems to be now established, is fog. So you have the devices on the ground, you have the backend in the cloud, and then you have a new layer, which is called fog computing, or some people call it edge computing. But the important thing is here that there's a computing unit with services, with information, that basically does the orchestration, the event buffering, that does the communication between the devices. Maybe not as good and as rich as the backend would do, but it keeps it running. And the most important thing is that it's running in your local or in your enterprise network. For home automation, I guess it's a very tangible example, but think about an assembly line in a factory. You don't want to, because something is broken with a Wi-Fi, you don't want the assembly line to stop working, since you can just do the orchestration on. I called it hub. I don't know if there's a word in between, but hub is called for most devices when you connect, for most systems when you connect multiple devices. Good news is if this one has connectivity and you're using something like Zigbee or so you don't have to worry about connectivity, then you just need to worry about the hub. Another thing to consider with the architecture is where do you want to be at when you move from a smart ecosystem to a multi-layer ecosystem? Do you want to be the platform? Do you want to be the company, the product in the middle? And since you can't do all the things in your domain by yourself, you have others integrating this with you. Because all of a sudden, things like developer experience becomes very important, because you need to make it easy for people to be connected to your platform. There's a very good HBR article about this. Or do you want to be the participant? I have a device. I have a device, maybe a household device, maybe industrial device, but I won't be able to build all this stuff around it. I won't be able to be the thing in the middle. And so I need to integrate to the biggest platforms. So in this case, probably for home automation would be Amazon, Google, and Apple, which seems to be the biggest player, and Amazon is pushing hard. Or I just try everything to do myself. I do the vendor login. I built the devices, I built the platform, I built the app for Android and iOS, and I expect just all the users to have 50 different apps for 50 different devices. This is what I see a lot. There's a strong trend from companies to move from the vendor login approach, then to realize, maybe we can't do everything ourselves, so let's at least be the platform in the middle, and this might be working somehow, but then they realize, I guess we should do an Alexa integration. I mean, if you make a deliberate decision in the beginning where you at least want to aim at, then you might save some energy and time and money on this. On my first IoT project, I spoke to the person that was in charge of writing the firmware for the device. And I was very excited. I was like, let's get going. Let's define some HTTP endpoints and some JSON structures. And the guy looked at me blank. I was like, JSON? That's just fancy candy for the internet kiddies. So he was saying, like, we should define a binary protocol. And then over the next month and with the next project, I realized that there is a divide between the developers. There's a divide between information systems and mobile system, and probably 2/3 of you can manage the right-hand side quite well. And then there's another portion of people that can manage the left-hand side as well. But when it comes to understanding each other, ways of working, ways of testing, continuous integration, then these worlds are quite different. And I think I coming more from the right-hand side, I have to understand that it might not be possible to have a JSON parse on every single device. It's just too small, right? So I have to be open for this. And on the other hand, I don't accept that something that was working before doesn't work with the next firmware update because I know how to do automatic testing. I can't see of a reason why this shouldn't be the case for embedded software as well. Spoke to a lot of people. Things are moving there, but I guess we have to be aware of this, especially when you then work with a different company. You should speak early about how do we integrate, how do we work together, how do we make sure that stuff that worked yesterday is still working on the other day. Or best case, you have one team that can do all of this. Which brings me to this slide. When I started programming for money, in most companies there was a very strong separation between front-end developers and back-end developers. And we probably all know the reason why this is not a good idea. So 10 years later, the idea of a full-stack developer is in a lot of companies well established, and there are many positive sides on this as well. The problem is, when I'm really a full-stack developer, as a consultant, going to different companies, I have to worry about back-end, front-end, mobile, cloud, ops, machine learning, computer vision, AR, VR, MR, PCB design, embedded 3D printing, and blockchain. I can't do this, really. This doesn't fit in my head anymore. And I guess it's getting worse. There are more niche topics. I can't be an expert on, I don't know, 3D design and machine learning at the same time. Well, maybe some people can, I can't. So the question is, where do we move on? I guess we always have to make sure that you have the skills you need in your team, but you just have to accept that not every single developer will be able to, take every single story. I guess right now we're still pushing for this. There will be the moment where this will end. Just be aware. And let me know if you have good ideas about this. Testing. Testing changed a lot in the last years. We moved from manual finding bugs to making testing, let's say, a fully integrated tool to design our software and to test our software. And if I think about testing, I think about those two things, the red-green refactoring manta, and I think about the famous pyramid with unit test, integration tests, and functional test. All good for most projects. If you then come to a smart ecosystem use case, you have something like this. So somebody does something on the machine talks to the back, and the back end talks to the phone. I have an interaction with the phone and the way back, and then the phone talks to the machine again. And then the machine gives feedback to the user. This is not made up, but it would be too long to explain this use case because we had exactly this use case in one of our projects. This is not fun to test at all. Well, first of all, you have those 3 different components, and well, there are very limited tools especially for embedded system, to do test-driven development and automation development. Not that it's not possible, but it's very limited. And then you can do all the things for the different devices. And the next thing is, if you have a system that has all these components and you want to test a very specific scenario, the machine is almost out of memory. And then the user does this. It's very hard to set this up for an automated test. It just gets very complex. Most of the time you have multiple teams with this. And then the most painful thing is, what if the test or the scenario needs physical user interaction? Somebody really has to press a button on this machine. Yeah, we were a bit stuck there. I want to give you 2 things that helped on the last projects, not fully eliminating the complexity of this, but that helped a lot to actually not throwing out automatic testing completely out of the window. The first one is fake components. This Raspberry Pi here thinks it's a coffee machine. And it does it's not brewing coffee, but it acts like a coffee machine. And the good news is, if I write a small software, maybe a node or something on this that should behave like the coffee machine, I can give it some extra endpoints. I can give it, just now think you are in brewing mode. Just now think you need cleaning. It's very easy to set this up in an automatic way. But obviously, here well, then we kind of cheated a bit. We can maybe test the whole flow in the system, but we are working with a component that is not the real machine. And so this comes then to the second suggestion, to do contract tests. So especially when somebody else is building the physical device, then you fake the device, do the testing for the stuff you're writing, and you write tests, first of all, for your fake device, and you then run them again against the real device. So at least can say, we expected something different. So we did that on different projects, especially for the coffee machine project. There was no single firmware update where all tests were green, but at least we now could know immediately, and we can point out test 7 and test 9 and test 12. Let's talk about this. So with contract tests, you get somewhat a living documentation, and you are at least able to automatically test the updates you, your team, or somebody else is doing. So I guess with those two components, you might be able to handle the complexity a bit. And I guess the other advice is push for more automation. Even though you can't do 100% of automation, then do the 90%. Then try to pop up a window that says, now somebody needs to go to the machine and press this button. Or I've seen teams building arms with Lego Mindstorm that do things. This is also fun. Ooh. Security. Nice. If we now think about the model again from the Fraunhofer Institute, if you have an information system and a mobile system, the OWASP website identifies those attack surfaces on these kind of systems. I guess you can go in more detail into that. Maybe some of them are missing, but these are basically the things you need to worry about where somebody can do something harmful to your system. When you now add an embedded system to that, you get more. You get these. So you have physical interfaces, you have memory, firmware, and so on, and so on, and so on. And the problem most of the time with physical devices is, well, servers sit most of the time on Amazon. Only very few people are able to go there, but the physical devices are at people's home, in warehouses, maybe on the street, and people have time and a screwdriver. They can just read out memory. They can just read the signatures and the keys and everything. So we worried a lot then in the projects about security, and it seems that one good rule is whatever comes from the device is insecure. Just expect that it's fake, because we couldn't think of a situation or a scenario where it's impossible for somebody to fake it. But then you end up with, those many threats and those many things that might go wrong, and it felt like, especially in the initial phase, you need to get a handle of this. You need to focus on something. So as a good consultant, then we draw a nice diagram with two axes, and then you just sit together and you just worry about, okay, if this goes wrong, what's the impact for our business and how likely is it? So for example, if I already have somebody in my Wi-Fi and somebody can do something that's not nice, but it's okay, the probability is low because not everyone is on my Wi-Fi, and if it's not too bad, then it probably ends up more in the middle. On the other hand, if somebody can take over my servers and place a bad firmware that affects all the devices, this is very bad, and it might be quite hard, but I guess this way, if you just think about the different problems, you might be able to identify these things on the upper right. This is where you want to fix these first or worry about the most. I have a scale at home, and it's connected to my Wi-Fi. I bought it long time ago. It was the first one that had internet connectivity. I don't know why, but I paid the money for it. At some point, I changed my Wi-Fi password and moved, and then, so this thing lost connectivity. The functionality was not too great. I didn't bother plugging the cable back in and setting the Wi-Fi again, so it's unconnected right now, but at some point it might be again connected. So this thing has seen no updates in 10 years. And there are bugs in the software. And since it's not connected for this scale, for this specific scenario, it might not be as bad. But I guess what I learned from myself and what I've seen in the real life also, no one cares about updates as long as it works. If the thing works just nicely, nobody will push the button. Nobody will go to preferences, settings, firmware updates, blah, blah, blah. So regarding security, leave the door open for yourself. Implement automatic and secure over the updates now. If you just need one feature, you need that one, because everything else you can hopefully fix then afterwards. And maybe as a side, don't forget about the basics. We learned so many things the hard way, and it seems that some of those things just got thrown out of the window as soon as we moved to the IT world. So don't forget the basics. So you need to sign your firmware updates with signatures. You need to send the signatures and verify the signatures. You need key rotation. You need secure connections. HTTP is not an option anymore. And no hard-coded secrets. Who thought that this would be acceptable again? I don't know. Privacy. I have the feeling that in Germany the people are not more technically skilled than in other countries, but it seems that people worry more about privacy. We are not too keen on credit cards. We like cash, and it seems that every time, especially in the IT world, something comes up, people in Germany worry about this, and I do understand, because we have those products. This is a Barbie doll that can record the voices of kids playing. Obviously, the Amazon Echo, I tried really hard to see when it's actually sending stuff to the internet and when it does not. But still, I can understand that people are doubtful about this. The Samsung TV that got in the news as well, because it was collecting and recording stuff it wasn't supposed to do. And you might not know this on the lower right side. This is an ODB dongle. It's something you put in the diagnosis port of your car. And I was not working on that one, but it looked very similar. We were building this, and the first use case we did, if you put this in your car and the car runs into a wall, a call center gets notified and will try to call you. And if you don't take the call, then it will take the latest GPS location and send an ambulance to it. Good, right? Second use case, it will collect the driving behavior. And if you're willing to take the telemetry insurance tariff for the car, then it will match actually the speed you are going together with the speed that is allowed on that road. And then you might get a good deal or a bad deal for an insurance. And I was like, 10 years from now, I won't be able to get an insurance without this, right? There's one formula for privacy, and it's very simple. There's only two components. So if you want to secure the privacy of your clients, you just have to worry about two things. Ready? Transparency. Make it transparent what data your things are collecting. Make it transparent what these are used for. This is from our website. Don't worry about what's actually standing there. But say it in real words people can read and understand. Not just in this long fine print, right? Because then people will know what this is doing. And if you do, I'm assuming we don't have any black hat people here. I'm assuming if you want to just, make a good product, why not tell people about it? Why not tell, I'm actually recording all the coffees you brewed, and you get bonus points for it. Oh, by the way, we use this for marketing research. What coffee is the most favorite one? That's okay if people know about it. Second thing, control. If people know what you are doing with the data, what you are collecting, and if you give them the option to disagree, this is privacy. I don't want the bonus points for my machine. Okay, we're doing marketing, right? People disagree, that's fine. If you do those two, you don't have to worry about any data privacy lawyer at all. I guess we went with this principle for the coffee machine. We went to a data privacy lawyer. I explained to her everything. She was like, yeah, sounds good. So it was not for this specific use case, we have a double opt-in on the second page of the privacy policy. This is stupid, right? I don't understand this. I don't want this. Maybe one more thing. Datensparsamkeit for the non-German speakers in the room. Sparsamkeit means to be not wasteful, to be careful. And Datensparsamkeit is obviously to be not wasteful and careful with data. Because, take as much data as you need for making a good business and for making a good user experience, but not more. If the marketing person comes to you, let's collect all the data and store it in a big data lake. Somebody will come at some point and analyze it. Just say no. If you can't tell me what it's used for, I won't do this. We all have the privilege to do this. I'm already done. So we covered all those topics very briefly, to be fair, but I hope I gave you a good insight, like what are important factors for building a successful smart ecosystem and how to approach IoT. I wish more of them would have been technical, but this is how it is. Thank you.
Thank you, Michael. I have a couple of questions here. One of them, when you do a fake device on the Raspberry Pi, does it actually run the real device operating system?
No.
Or is that being faked too?
No, good question. It's fake. It's literally just the interaction between the fake device and the rest of the system needs to be the real one. Yes, you are missing out a lot of things. You're missing out special problems you might have with the operating system, but then I guess you just have to write more contract tests. And yes, it doesn't solve the problem completely. It just puts you in a position where you are able to at least do some end-to-end testing. As I pointed out, it's no silver bullet. It's just a good approach to tackle some of the things. Good question.
Okay, here's another one. You talked about we want to make the company's IoT platform the platform.
Yes.
All cloud or service providers provide the platform. Azure, Amazon, yeah. IBM. Do these platforms work?
I looked at a lot of them, and I haven't looked at all of them all the time, so I don't really know how they evolved. But most of them, let's say the marketing department was a bit faster than the technical department. And I've seen, so honestly, Amazon IoT works. I could get something running within 30 minutes. There's a company from Berlin here, Relaya, also within 30 minutes I was able to get something running. If I looked at Eclipse Home, I looked at it for 30 minutes and had no clue what they were saying. So I guess I think it's worth checking. You don't have to rebuild everything yourself. I would always go for the smaller approach. I would rather look at the MQTT frameworks and maybe at the queuing systems that are there and plumb together whatever something small I need rather than go for the full platform. Because if you do something small in the beginning, you might be able just to jump on a platform, or you're sure that you don't need it. I half answered the question, sorry.
That's a good answer. Here's one I need to read because there's so many words in it. Is there an open standard, are there open standards for communication and interaction between layers or across domains that will facilitate the broader cross-domain smart ecosystem?
Oh, good question. From device to cloud, or from device to backend, if you don't have something in between, I guess most common are AAMQP, MQTT, and HTTP. That's the protocols that are standard. Regarding then on a deeper level, on the domain level, the formats for specific domains, I think a lot of consortiums are trying hard. I have not seen something in real life that really is a standard. And I guess from backend to a service to an app, we most of the time speak HTTP. Within the devices, lots of systems, hub systems, have then something like Zigbee. Others speak directly HTTP.
Cool. I have a very specific question. The last one. Do you prefer Node.js for IoT?
Yeah, good question. So the last project I was on was actually an IoT blockchain project, and it's not just throwing together buzzwords. The blockchain world seems to be Node world right now, so I like that. For faking components, I like Node.js because it's just fast to build this. It's not a complex software, and if you get something running fast, I actually like Node for this. Backend systems that are growing, that get complex, and you want to build them with multiple people, I still think Java is a good idea.
Cool. Thank you, Michael. You had some very interesting points here.
Thank you.